Hi there, and welcome to our video about Python fundamentals. I'm John Selkis and I work with Eduonix. You can find a lot of our great course content both here on YouTube, and if you want to see the full courses, check them out on our website, Eduonix, as well as Udemy. So, a little bit about myself. My name is John Selkis. I work for my company, C Solutions LLC. In this field, I work with everything involving Python, whether it's data science, in the general sense, machine learning, statistics, advanced modeling, natural language processing, building some user-friendly GUIs, you name it, I've done it. The primary things I work with are dealing with raw, unstructured data, finding ways to make it usable, and then processing it on the back end. Some of the skills I use on a day-to-day basis involve this Python fundamental skills we're going to focus on today, which is going to be data structure. So we'll talk about things like lists, sets, tuples, as well as one of my personal favorites, dictionaries. Outside of this, I also work as an instructional mathematics coach. In this position, I teach things from algebra to statistics, every level of student. So anytime you take a course with me, I ensure you that anything I explain, I'm going to do it in a way that'll benefit both those of you with a strong background in Python, as well as those of you who may be new to the subject. So hopefully at the end of this course, you'll walk away with a deeper understanding of the fundamentals of Python, specifically when we're talking about data structures. Please go ahead and subscribe below and check out any further links in the comments section as well as the description below this. Now, if you want to go ahead and open up your favorite Python notebook, I'll be using Google Colab. However, if you're running a Jupyter notebook locally, either way it works with the stuff that we're going to be doing today. Looking forward to learning together.
So when it comes to Python data structures, the things we really want to consider are which one we're dealing with. Everything you'll see me doing today is going to be completed in Google Colab. However, this works in any Python interpreter, so if you're using Jupyter Notebook locally, it's the same thing. If you're running Google Colab, it is a pretty cool free tool. You've probably seen me use in some other videos. However, again, either way works. You could run this locally in pretty much any interpreter, and you'll be good to go. However, this is where I'm at. So when we think about this, pretty much every single programming language has provisions for data structures, the way that that language is going to work with and interpret data in its different forms. If we're thinking about Python, there's a total of 4 different inbuilt data structures that we commonly work with. They are a list, a tuple, a dictionary, and what's known as a set. Or we'll say set there. I'm going to go ahead and run that. Just keep my notes nice and handy up there. Each of these, if we think about it, they're pretty unique. Sometimes it's preferable over others. As someone who works in data science a lot, the two I will say that I most primarily use are list and dictionary. However, that's not to say that tuples and sets aren't useful as well. So we'll cover each in a little bit of depth and see a little bit of application with each. The first one we're going to start with are lists. So when we're working with a list, the first thing we want to think about here is that a list is a data structure that stores an ordered collection. So ordered collections is a big important thing there, meaning that we can identify things based on where they are. So not necessarily matching it perfectly with the item itself, but rather its location in the list. So we have a sequence here of items. Again, we're just taking some nice little notes here with our hashes so we could look back at later. When we put these things in, we're going to use square brackets and put commas in between. So let's go ahead and create a list. So I'm just going to call it also advice in Python. Don't name your list list. That's an inbuilt kind of like keyword there, so we don't want to do that. So I call mine list one. Or you could say L1 or whatever you want to name it. As we know with variables in Python, it doesn't matter what they're called. List store a variety of cool stuff here. So we can have strings, integers, floats, variables, pretty much even other lists nested within a list. So let's just start with the basic one. Let's get in there maybe a cool animal like cat, maybe a number like 7, and then a fruit. Let's go apples. So when I run it, I can go ahead and print out, there's my list 1. Now, when we talked about an ordered thing, that means I can go ahead and reference things such as list position 0. And we could see that that's cat. So lists start with the positioning of 0. So pretty much just like everything else in Python. The first item is 0. We could also use reverse or negative indexing. So I could say -2. And we'll notice that that gives me 7. So if I start at a negative, this would be -1, -2, -3, all the way through -n toward the end. So that kind of gives us a cool way of indexing lists, pulling things to and from them. If we want to make a list within a list, so looking at that idea of a nested list, here we could say something like, maybe let's put some other fruits here like pears. Let's get a different type of decimal in there. And then I want to put list 1 inside of that list. So now if I check out list 2, you'll see it shows visually when I display it my parts of it, and then it actually shows that nested list, list 1. So after we've made a list in Python, we can actually go ahead and search, add, and remove items from that list. So we've seen about the searching there through indexes. However, we can also add certain things in. To add some things in, what we're going to do is called append. So this is a method that we can use in combination with a list. So key thing to note here, lists are mutable. As soon as you're in the field of anything involving data, you're going to hear things of mutable and immutable. So, and again, there's no right or wrong. However, you want to know which type of data set you're working with or data structure. So mutable means it can be changed and updated. Immutable means it's a set exactly as it is type thing. It cannot be edited. If we want to change something, we have to create a whole new one. So depending on your use case, that might actually be beneficial one way or the other. Let's go ahead back to this list and see how we can use its mutability to our advantage. So here, let's say I want to add something to list 1. So I'm going to say list1 dot append, and then I'm just going to say what to put in here. So maybe I want to put in a new item. Now, what's cool about this is the way it updates. So here's list 1. We have our old list 1 up here, and we can see a new item. So append forces it at the end of the list. Now, list 2 contained list 1. So if we check out list 2, we actually see that it updates there as well. So we've seen that that new item popped into our nested list within list 1. Some of the different methods here that we had, so we talked about dot append. Oh, whoops, I'm going to get outside my parentheses there. We could also use, let's see, what's another cool one? We could have dot clear. So what dot clear will do is this is going to get rid of it, so it removes all elements from the list. So this and adds an element to the end, just as we've seen there. Clear will remove all the elements from the list, so if you want to start over. We can use dot copy, so that will create a copy of it. So again, the same thing as we have there. We could use dot count to see how many things are in a list. We could use dot extend. So dot extend is a cool one. This adds all elements of a list to some other list, so I could combine them. So if we want to see that one, I could use list2 dot extend and then list 1. Instead of having that nested list, it would just combine them in there. If we use dot index, sorry, put a space there. So for dot index, this returns the index of an element. So for example, it'll show them the first match there of 0, 1, 2, whatever it may be. We could use dot insert. What that's going to do, it can insert an element to the list at a specified index. So if you're looking to use that one, I would suggest looking up some documentations to kind of see it. For our next one here, we could also use dot pop. So with that one again, sorry, I put a space there again. Let's get rid of that. So that'll eliminate and return an item from the list. So it'll pull something out. We have dot remove. What that's going to do is it can again eliminate a specific item from the list. We just don't see that return feature of it. A cool one to use, I actually used the other day, is dot reverse. So it reverses the order of all elements of the list. So I used this when I was working with a data frame, and I wanted to, after doing some math on it, ranking with a certain algorithm, I wanted to just throw in a column that said rank. However, I wanted it in a different order, so I wanted to get it from bottom to top. So I want to start with 100 and go all the way down to 1. So what I actually did there was just reverse that list before I attached it as a column on my data frame. So nifty little tool there to kind of work through that. Just a cool little bit of feature there with reverse. And then we have dot sort. So what that'll do, it'll sort it all just in a certain given order. So reverse and sort, kind of cool things there. They can go hand in hand. So hopefully you're feeling pretty comfortable with the different aspects of a list, kind of how we work with them and what those data look like. Now, the next thing we're going to talk about here is tuples. So they're similar to a list, such that it's a built-in data structure in Python. However, the challenge here is it doesn't have that same level of extensive functionality. So like I said, lists and tuples kind of go together. Typically, I prefer a list. However, again, it's not to say that tuples aren't really useful. It's just a usage case and kind of what you need to it. So the key idea here, the difference, so we're going to say similar to lists. The biggest difference is mutability. So here, we have what's known as an immutable. So we're going to say that tuples, let's go to a different line. So tuples, oops, spelled wrong. They're immutable, so cannot be changed. So when I make a tuple, it is what it is. Now, when I see myself using a tuple, it's pretty much if I want to have a set list of items kind of thing, or like a set very concise and non-changeable thing. So for example, if I'm labeling different variables, I might use a tuple with that. Main reason why is because then I can't accidentally change anything. So key idea there, sometimes lists is we're doing things each time. When you update different pieces to that list, or you might use it in different spots, occasionally you change something and you might have to go back and change it again. Whereas with a tuple, these are things that, again, they don't have to be changed. We want them to be exactly the same throughout our work. So in a lot of cases, a tuple in Python programming is defined using these parentheses. And then so instead of the brackets like we seen up there with the list, we just use parentheses. So let's go ahead and check it out. If I want to make a tuple here, I call myself, so again, notice tuple, keyword, so we throw a number at the end of it. Or you can say T1. So for tuple 1, let's say I wanted to make it the number 1, cat, and then green, right? So then if I display it, I could go ahead and see my tuple there. If you want to make an empty tuple, that's always something useful here. So you can just make it empty. So I could say tuple2 is equal to, and just put some blank parentheses. So if I check that out, we can go ahead and see an empty one. It'd be the same way of making an empty list. The one little nifty caveat is if you want to make it a single list item. So watch here if I just put dog and then run it. Sometimes it comes out good. However, if we want to get technical, theoretically, you're supposed to go ahead and put this little parenthesis in, or not parenthesis, comma in there, because we can see that comes in that way. So either way is working fine. However, again, we just kind of want to see there. Either way works. We get that comma in there. Just the way tuples are defined, it kind of likes to see those commas. Looking at tuples and strings and the similarities between them, because again, we kind of look at tuples as like a stringy version of a list. One of the things here is that we want to think about the similarities. So indexing, we could index and slice them and concatenate them. So some things to look at of the methods that are applicable to tuples are we have compare is kind of what the shortcut is for. So if we use that dot compare, this compares elements of two tuples. We could also use length with them, so similar to how we've seen it with a list. In that regard, we could look at max, and what that's going to do is return the biggest value from a tuple. We could also see min. So again, we have a couple different options there. We can also convert a list to a tuple by using dot tuple on a list. So a little less functionality, but nonetheless, still pretty cool stuff to work with. Again, if you're looking for that immutability characteristic, this is a great place to use a tuple over a list in that regard. All right, let's look at our next thing here. Here, we're going to talk about sequences. So in this key regard, we think that about lists and tuples are both considered sequences, just like when we think about a string, basically because they have the concept of a beginning and an end. The most distinguishing features of these sequences are like our tests and indexing operations, so looking if an item is included or not, comparing what's in one list or tuple versus another, and again, being able to pull, concatenate, and slice them. So when we look at these, we have lists, strings, and tuples all fall into the category of sequences. Because each of those, again, they support that slicing operation and retrieving a given value, portion, or chunk, so that slicing idea of that pattern. Now, some spaces in here, and let's go ahead and talk about one of my personal favorites, dictionaries. So when it comes to a dictionary, this is another built-in type of data structure within Python. The key idea here is we have key value pairs. So when I say that, I mean that if I call something key1, I can then tie it to a value. So the keys defined for a dictionary need to be unique in the sense that you can't reuse the same key. So I can't call everything key1 or key2. Basically, you want to think about if you were making yourself a set of like acronyms or shortcuts, they're each going to be unique. Because if I use the same acronym, so let's say I made myself an acronym. So PIA, Python is awesome, right? I wouldn't also want to use that for pink indigo apple, right? You can't use the same thing more than once. So whatever acronym or key value we're using, we want to tie it to a singular unique value in that way. So with these dictionary things, we can actually have mutable or immutable objects. So only immutable objects are allowed for keys, meaning that our keys are going to be the same. We don't want to change them. However, we can change the values that they go with as needed. We use some commas and we use those curly braces when we're building these things. So let's go ahead and build our first dictionary here. Something you'll find dictionaries really useful for is when you're creating kind of like makeshift databases. If you're ever going to work with data frames, so on the data science side of things, you'll see yourself using a dictionary a lot. It's a great way to go ahead and start building out things as well as referencing, like in terms of like visualization. I use dictionaries a lot as well. So let's build something called fruits. We'll make that our dictionary. So the first thing I do is put in those curly brackets right there, as you can see. I'm zooming in a bit just so you can see the curly part to them. So real quick reminder, this is for a list, this is for a tuple, and then those curly braces we see now are going to head and start building our dictionary. So the first thing I do is type in a key. So maybe I'm going to call it key 1, and I'm going to associate that with the value of apple. Then I put a comma between, so notice the colon here is what's separating my key, which is key 1, with my value 1, which is apple. Then maybe I want to make key 2. And here what I'm going to do is maybe use a different fruit of pear. Notice the comma then, I'm getting in now to my next key value pair, so key 3. Let's go with grape. Cool, no errors. And if I display it, we could go ahead and see here our dictionary. So something else too, if you're ever building something, you want to examine the type. That's always a cool way to do it. You just put type in parentheses and then boom. So we can get a dict. If I go back here and check out some other options like list 1, I can see that's a list. If I go ahead and check out tuple 1, we can see we get a tuple. So again, that type feature to kind of figure out things that way. But let's go back here now. Let's check this out. So we talked about indexing, right? So when I worked with lists and tuples, if I did my indexing, I could see which element was in the list. However, with fruits, if I try that, in theory, I would be like, okay, so I'm pulling fruits, I'm pulling the first thing. Maybe I'll get this whole part, or maybe just the value, maybe just the key. I don't know. In reality, what it spits back to us is a key error. We can't actually index a dictionary that way, but what we can call is on the keys. So even though it appears to have order, we actually don't have order in a dictionary. It's just a storage bank of key value pairs. So when I call on that key specifically, I can then pull out that value that goes with it. So 1, 2, and 3. If you see me just type key, it gives me an error because that doesn't exist. I don't have just the word key anywhere in here. So again, we need to actually reference those keys handily. So when you're naming your keys, please make sure there's something that are easy to use and recognize so that when you're trying to pull them, it makes sense to you. All right, let's check out what if we made 2 dictionaries. So maybe I want to make some costs. So I'm going to deal with my apple, and I'm going to say that that costs, let's do some numbers here. So 5. You can see 2 dictionaries are great for storing a variety of variable types. Pretty much anything you're going to typically use is going to work just fine. And let's say our last one here, we have grape. Right, so apple, pear, grape, apple, pear, grape. We'll make grapes the cheapest because grapes are kind of small. So maybe grape is only 0.5. Cool. So let's check out costs. We know it's a dict because the way we built it, but again, we can kind of see it there as well. So let's go ahead now and put it together. Something you'll notice here, alphabetical. So when you print out a dictionary, even though I put grape as my, or pear as my second thing, we think about the English alphabet. Pear actually shoots after grape. So apple, grape, pear. So again, it defaults to alphabetical when being displayed up here, and it's based on the keys. Because up here we kind of seen key 1, key 2, key 3. So there, those fruits alphabet, they didn't really care about it. They were looking at the keys. So here, same thing. We're looking at keys. So it's alphanumeric in the sense because we could see key was all the same, but then 1 came before 2, came before 3. So depending on how you name your keys, you can kind of, forcibly make something ordered for your own usage. That's one thing I'd recommend if we're dealing with keys such as that. I would say if there's some kind of logical order that's going to make it easier for you to find things, I would suggest using that alphanumeric concept there with your naming. All right, let's see how we can put some things together here. So maybe I want to print out the way I'm going to see this. So maybe I want to say print, and then I want to print fruits, and I know I'm going to use key 2 because that was my pair, and then I want to see it next to the costs for a pair. So we can print them out that way. So pair is costing us 2. Now, something cool with dictionaries here is you can actually make something a lot more, I guess you could say, complex. So we could make a really fancy dictionary. So we're going to call this, all right, let's call it the advanced dictionary. Now, so let's start off with our squigglies. And for shorthand, I'm just going to say K1 instead of key 1. So let's say I wanted to make this first one like a float, so maybe like 17 point something or another, right? So 17.34634. Very precise, but that doesn't make sense if we're dealing with money, so maybe let's just make it 0.35, right? Or you can make it longer, totally your call. For our next item, we'll call it K2. And then let's go ahead and insert string here. Maybe we'll call this dog. So you're noticing I'm just combining a ton of different data types. So in K3 for item here, maybe let's put in a list. So we'll put a list within a dictionary. This is a nifty little feature I've done on a few different occasions. And then lastly, let's go ahead and throw one more here. We could put a dictionary inside of a dictionary. So over here, we'll go ahead and throw in our dictionary. That should be a colon. And then I want to go ahead and put some squiggly brackets here. And then let's put our inner to represent our inner dictionary. And next to that word inner, we'll go ahead and put awesome. Oop, it's not liking my syntax. You can see here that I actually put that instead of a comma. So let's go ahead and fix that. And then let's check out some cool keys here. So for my advanced dict, let's go ahead and pull key 1. So I could see it come out there. We could also see if I want to pull key 2, 3, or if I actually go ahead and pull key 4, you'll notice it spits out the whole dictionary. If we subset that, E4 pulled that whole thing. If I wanted to actually get to the word awesome, I could call that inner dictionary right next to it by saying inner. And that would get me just to that nice little phrase there of awesome. So dictionary is a really powerful tool, great working with data frames when you're trying to input data in certain ways as well as define things. Live in their own little world there in terms of that key value pair. The last thing we want to check out here is going to be sets. So when we think about a set, if we want to compare this with a list, a set is basically going to give us iterability and mutability. It has no duplicate elements as well. So any set defined in Python is what's known as an instance of the set class. So again, a set can be typed or identified as a set. Comparing it with a list, it's advantageous simply because it's highly optimized method. So there's no repeats in there for checking whether or not something's in there. So if I wanted to have something, just a list of values, I guess you could say, to see, okay, maybe names of employees, maybe types of employment, um, things I'm like, if I'm looking at like the checklist idea, so certain things that need to be completed, I can look at it as that, and it's really quick and really fast, especially if you have large sets of things in terms of like the quantity of individual elements. Sets are really fast for checking whether or not something's in there. So again, depending on your usage case, list versus set. Let's go ahead and check one out. So I'm going to call set1, and we define it with these squiggly brackets. And I could say cat, dog, frog, and then maybe let's put some numbers in there. So cat, dog, frog, 1, 3, 5. So first off, let's check it out whether or not it is a set. So if we do our type on set1, fantastic, we get set. So our syntax is squiggly brackets, and then we go ahead and put those in there. So it's similar to a dictionary when we build it with those squigglies. The difference is here we have key value pairs, whereas here we just list out those items. And when I would say to use a set over a list, the key idea here is that when we're looking at existence being more important than quantity. So I'm thinking of a checklist, for example, if we're in manufacturing and we're looking at did a certain process complete, I'm much more concerned with the idea that yes, a version control check was executed versus the time it occurred or how often it occurred in the process. I need to see that it did happen before something else happened. So Again, when existence is more important than quantity, sets become pretty useful. So again, you can look at membership. You can see whether one set is a set of another set, so that idea of subsetting. If we want to look at some different methods that we can use, we could think about using .add. So what that'll do is it adds an item to that set. Although remember, we don't have repeating values. So if you're looking to add something, it has to be something that's not already in there. Otherwise, it just won't show up. We can use .clear. So it removes all those items. We can look at difference. So the idea there of difference is it going to return a set with all the elements of the invoking or the base level set, but not of the second set. So it's looking at the difference between those two. We can look at intersect. So again, if you're looking for specific use cases of this, this is kind of showing you the general differences. If you check out the documentation, you kind of see some different examples here. And then last, union. So combining them two. So if we think about these different options, basically when you're working with sets, they're looking at what's in something. So the intersection is what's in both, difference is what's only in one, and union is in what's all of them together. So if you think about your Venn diagram, A and B, and then the overlap of those two circles, that's where these three come in handy. So hopefully you've kind of seen now some different options for when you're using a different variety of these 4 data structures within Python. Hopefully you walked away from something with this video having a new understanding of these 4, and please check out all the future videos coming from myself and Eduonix to help keep guiding you on your path to mastering Python.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.